Here we have AP calculus AB problem. Okay, let's go with the question. Find the indefinite integral use C for the constant of integration. Here we have integral tangent 3 theta times d theta. Okay, to integrate this function, what I'm going to do is I'm going to consider the coefficient identity in trigonometry, particularly for the tangent function. That is, tangent theta can be written as sine theta over cosine theta. So this is called coefficient identity in trigonometry for the tangent function. Since we have tangent 3 theta over here, so it can be written as sine 3 theta divided by cosine 3 theta times d theta. So here we have theta, so we write sine theta over cosine theta. Instead of theta, we have 3 theta. So we use the same identity over here, but replacing this theta over here and here by 3 theta. Now let's see how to integrate the function we have over here, that is sine 3 theta divided by cosine 3 theta. I think a method of substitution can be used to integrate this function. Okay, to use method of substitution, so the derivative of a part of the function has to be multiplied in the function itself, and we must be able to write the derivative along with this d theta using multiplication. So for that, let me consider the part we have in numerator, that is the trigonometric function sine. What is the derivative of the trigonometric function sine? Its derivative is cosine. It's over here, but can I write this derivative along with d theta using multiplication? No, it's not possible because cosine is in denominator. Okay, now let me consider the other way. So let me consider this, the part we have in denominator, we have the trigonometric function cosine. What is the derivative of cosine? It is negative sine. Okay, now we can ignore negative, we just consider sine. So its derivative is in numerator. Can we write this derivative along with d theta using multiplication? Yes, we can do. Okay, so we can do use substitution for the stuff what we have in denominator. Before that, let me rewrite the given integration as 1 over cosine 3 theta times sine 3 theta times d theta. Okay, now what I'm going to do is I'm going to substitute a new variable for this cosine 3 theta. Let me do it. So let u equals to cosine 3 theta. Okay, since I substitute a new variable u, so the entire integration has to be changed to the new variable u. So when I change the entire integration to the new variable u, so instead of d theta, I must have du. So if I want to get du, what should I do with this u? For that, I have to get derivative of this u. Since we have the original integration in the variable theta, I have to find derivative on both sides of this equation with respect to theta. When I find derivative of this u with respect to theta, I am getting du over d theta. When I find derivative of this trigonometric function cosine, it will be negative sine, and whatever stuff we have over here, it has to be written as it is. Now, by chain rule, I have to further derivative for this 3 theta. So here 3 is a constant multiplied by the variable. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to get the derivative of the variable alone. So here the variable is theta. When I find derivative of this theta with respect to theta, I am getting 1. So when I find derivative of this function, so the first I get the derivative of this cosine, that is negative sine. By chain rule, I have to get derivative of this 3 theta, that is 3 times 1. Let me continue. Du over d theta equals to, we can multiply this 3 and 1, that is 3. That 3 can be written in front of the sine over here. Then I'm getting negative 3 times sine 3 theta. Okay, now to solve for du in this equation, I have to get rid of this d theta that we have in denominator. For that, I multiply both sides of this equation by d theta. Then d theta over here will cancel out. I'm getting du equals to negative 3 times sine 3 theta times d theta. Okay, here when I look at the given integration, I have sine 3 theta d theta. So here also we have sine 3 theta d theta. But apart from that, there is negative 3 multiplied over here. So I have to get rid of this negative 3. For that, I have to divide both sides by negative 3. Let me do it. Then this negative 3 will cancel out. Let me continue the stuff over here. This du over negative 3 can be written as negative 1/3 times du. On the right side, we have sine 3 theta times d theta. Okay, now let me go to the given integration, that is equal to integral 1 over, for this cosine 3 theta, I can plug in u. So that's a variable we have substituted for cosine 3 theta. So we get 1 over u. And for this sine 3 theta d theta, we can plug in this negative 1/3 du. Let me write it over here. Negative 1/3 times du. Okay, so here So this is a function, it is multiplied by the constant negative one-third. Whenever there is a constant multiplied by the function in integration, the constant multiplied by the function can be moved out of the integral. So when I move this constant negative one-third out of the integral, I'm getting negative one-third integral 1 over u du. Let me continue. Negative one-third. The integration of 1 over u with respect to u is a natural logarithm of absolute value of u. Since it's an indefinite integral, we must add the constant of integration, that is positive c over here. Now, if we may have a question, why do we take absolute sign for the u over here? Actually, logarithm is defined only for the positive value of its argument. What is argument? So the value we have over here is called argument. So it's a natural logarithm. So this natural logarithm is defined only when we have a positive value over here. Even if u is negative, because of the absolute sign, it will become positive. For this purpose only, we are taking absolute sign for u over here. Okay, now let me continue the next step. Negative one-third natural logarithm of. So this u is the variable taken by us. It has to be replaced by the original stuff, that is cosine 3 theta. That is, we have to plug in this cosine 3 theta for the u over here. Then I am getting absolute value of cosine 3 theta positive c. So the integration of the function tangent 3 theta with respect to theta is negative one-third natural logarithm of absolute value of cosine 3 theta positive c.